So it says a telephone pole has 3 cables pulling as shown from above, from above, with F equaling. So let's just draw a diagram. This one's going to take a bit actually. So F sub 1 force vector equals equals 300 0 I, and then 500 plus 500 0 j hat. Okay. F sub 2 force vector equals negative 200 I hat, and F sub 3 negative 800 j hat. Find the net force on a telephone pole on a component form. Okay, easy peasy lemon squeezy. So this is like literally just adding these all up. Like, I don't know how this could be even more complicated. So let's go ahead and add them up. So 300 minus 200 minus 800. Oh, that's J. Okay, and then 500 minus 800. Okay, negative 300 J, 100 I hat. So what is this like? So X is positive and Y is negative, so it's like that. We find theta. We know that this is 100 negative 300. And theta angle is going to equal arctan of negative 300 over 100. And it's negative, so we have to not add 180 because our y is negative. That's fine. It's only if our x is negative. South of east or something like that. What does the answer say? It doesn't really say anything. Okay. I mean, this is fine. I'm guessing that's the correct way to do it. So we have our direction. Let's find our magnitude, and that's simply c squared equals a squared plus b squared. And so if we want to find c, the magnitude, r, so r equals square root of 100 squared plus negative 300 squared. This is so F net equals 316 newtons, and we add that to the end, so 71.6 degrees south of east. So that's our answer. Alright, so rocket sled. The rocket sled shown below accelerates opposite to the motion at a rate of 196 meters per second squared. What force is necessary to produce this acceleration opposite to the motion? Assume that the rockets are off. The mass of the system is 2.1 times 10 to the 3 kilograms. So it's saying its acceleration is 196 meters per second squared. It's saying what is the force? So chapter 5 is really easy. Oh my goodness. 2.1 times 10 to the 3 kilograms. 196 meters per second squared. Alright. So F net equals 412, 4.12 times 10 to the 5 newtons. So problem 57, a team of 9 members each engage in a tug of war, pulling in opposite directions on a horizontal rope. Each of the first team's members has an average mass of 68 kilograms and exerts an average force of 1,350 newtons horizontally on the ground as they pull on the rope. Each of the second team members has an average mass of 73 kilograms and exerts an average force of 1,365 newtons horizontally on the ground as they pull on the rope in the opposite direction. A. What is the magnitude of the acceleration of the two teams, and which team wins? B. What is the tension in the section of the rope between the teams? Okay, so we figured it out. We're gonna have to use ChatGPT because it's just it's good for studying. Okay, so team A, let's just call it team 1 actually. Team 1 has an average force per player, so let's just write per player. So average force, let's just write F equals 1,350 newtons, and their average mass equals 68 kilograms. And then for team 2, per player, the force exerted by each player is on average 1,365 newtons, and their mass is 73 kilograms. So the strategy here is to find the total force per team, and then find the difference of those forces. So 1,350 times 9. So we find that the total, let's just write this out, total F equals, I guess this is F net. Sorry, we want to make sure we write this correctly. So F net of team 1 equals this large number, 1,000,000. Sorry, no, that's not it. This is the number. So 12,150 newtons. And then over here, same thing. You're just this number times 9. So F net equals 12,029 290 newtons. And then we also want to find the total mass for each. So 68 times 9, that's 612 kilograms. And then for this, 73 times 9, m tot 657 kg. So the reason we did this is because if we write out the formula for Newton's second law, we see that we have the total force. We have the forces, right? We have the forces. We want to find the difference in the force, and then we can get that acceleration by plugging in the total mass. Because we want to use this as a total system. And we know that team 2 is pulling in the opposite direction. So it's actually negative. sorry, let's actually make this positive because we know that it's going to pull in that direction. So let's say this is negative. Alright, so yeah. The real equation is actually F net equals, what am I doing? Equals sigma mass acceleration, something like that. All the forces. So if we add the forces, so 1290 newtons minus 1500 or 12,150, and then should get should get 130 newtons. So this is the force that's going in, going towards team 2. So now that we have the force, we know that team 2 is winning now because we have the force. It's in their direction. Now we just want to find the acceleration. So to do that, we need the total mass of the system. So we actually have to add up the mass of each team. So 612 plus 657, and this is kilograms, and then we should get an A, and let's just actually divide that force. That's what we're going to have to do. So we divide that force. Whoops. Jesus, okay. And we should get A. So let's go ahead and calculate that. So just get the answer, the solution. And we do indeed get an acceleration of 0.106 meters per second squared in the direction, you can just say toward team 2. So that's part A done. A sailboat has a mass of 1.5 times 10 to the 3 kilograms and is acted on by a force of 2 times 10 to the 3 newtons towards the east, while the wind acts behind the sails with a force of 3 times 10 to the 3 newtons in the direction 45 degrees north of east. Find the magnitude and direction of the resulting acceleration. So with these kind of questions, you always want to draw a diagram. M equals 1.5 times 10 to the 3 kg. There's several different forces. Let's see, F net equals toward the east. So we have a force, let's just call it F sub A. And that's toward the east, so we just write an arrow. Toward the east. And then another one behind the sails. So it's like pushing it. "45 degrees north of east." So this is a northeast force. So 45 would be in the middle of this quadrant. Alright, and then this is going to be, just get rid of that line, it's kind of throwing me off. Okay, and then this is going to be 3 times 10 to the 3 newtons. And we want to find the resulting vector. So fairly easy stuff. We have theta, we have r, so we can find any resultant, or sorry, any I hat, j hat stuff. Yeah, this is not, this is a right triangle, but let's not do that. Let's go ahead and calculate the components. Alright, let's do this. So yeah, the magnitude is, sorry, 4.635 times 10 to the 3 newtons. So we know the force, now we need to calculate the acceleration. That's just the force divided by the mass. So 3.09 meters per second squared. And so we have our acceleration, and now we need to find the angle, which is simply these components, the arctan of those components. Do 1, you will get 2.723 times 10 degrees, whoops. Alright, so I combine everything. I'm just going to move it down here because we need to hurry up. And 27 degrees north of east.